So it'd be really easy to overcomplicate woven wire mesh by going into the weave pattern and geometric pore size and aperture size, but if we were to take all that away and strip woven wire mesh down to its bare elements, what is left over? The wire. It's the fundamental element of woven wire mesh, and it's the first step to understanding the engineering behind it. So in this first episode, we'll be going over, you guessed it, wire diameter. Wire diameter is the distance of a line that passes through the center of the wire, and its endpoints are on the circumference of the circle, or the longest chord of a circle for those of you who are geometrically inclined. I'll get to that in a second. The diameter can vary a crazy amount between weaves, with a diameter as big as a 1/4 inch all the way down to 5 micron, which is literally 1/10 of the size of a human hair. And the precision needed to weave wires that small takes an incredible amount of precision, and I mean a lot of time. Depending on the length of the weave, it can take over 3 months to weave a roll of 5 micron wires together. And on the other side of the spectrum, larger wires need to be pre-crimped or bent at the intersections and be fed through a special crimping machine before they can even be fed into a weaving loom. But since we're talking about wire diameter, we have to talk a little bit about the wire itself. And just to make things a little bit easier, there's different names for the directions that the wire travels in. This is very important. I'm gonna be bringing this up a lot. Warp wires go vertically and weft wires go horizontally. Warp and weft sound a little weird because they're derived from Old English, but you can look at it also like warp is the length, while weft is the width. Weft, width, weft, width. That's not a joke, I can't say it. And weft is sometimes called a shoot wire, depending on where you're at in the world, but for this video series, we're gonna stick with warp and weft. The reason why I bring that up is, depending on the needs of the mesh, the warp wires can sometimes have a larger diameter than the weft wires, and vice versa, weft wires can sometimes have a larger diameter than the warp wires. Now, why does wire diameter vary so much? Come on, I'll show you. So in the mining industry, you will see a conveyor belt transporting broken up chunks of rock onto a device called a vibrating screen. The vibrating screen is made up of woven wire mesh, which can sort the smaller rocks from the larger rocks by use of vibrations. Those smaller rocks will eventually find an opening that they can pass through, while the larger rocks stay on top and are sorted elsewhere, depending on the application. The wire diameter has to be large enough so it can withstand the weight of these large rocks. So if the wires were changed to a diameter of, let's say, 0.05 inches, then the rocks would bend the mesh until they could no longer screen properly, or they'll just break entirely. Not very good. But if you look at the world of solar panels, motherboards, and microchips, that's where the ultrafine mesh like 5 micron come into play. It may not look like there's any mesh being used in these products, but if you look closer, a little closer, you'll see these really tiny lines interconnecting all over the surface. And if you look even closer, you'll actually see the footprint left over by the mesh that printed these patterns so that the electricity can flow to where it needs to go. This is called screen printing. And there's no other way to print these patterns without using a wire diameter that is incomprehensibly small. But these are just the outliers. Usually you'll come across a wire diameter that's a bit more reasonable. Now you're probably thinking, Andrew, what about all the woven wire mesh that has different sizes for the warp and weft wires? What in the world are those even used for? So one of the biggest uses for multi-diameter woven wire mesh is for filtration. And if you're using woven wire mesh to filter something, odds are you're using a type of mesh called woven wire filter cloth. The mesh is really complex to weave. It's incredibly small, and honestly, it's really complex to describe, so we're going to be going into that into the later episodes. But a major aspect that makes the filter cloth work so well is the multi-diameter wires. So this is a very common filter cloth weave pattern. If you look top down on the mesh, it almost doesn't look like there are any openings to this weave, but if you look at it from an angle, you'll see these little triangular openings that are almost like they're hiding in the center of the mesh. These openings would be practically non-existent if the warp and weft wires were the same size. So these openings are actually gauged by how big the warp wires are in the weave. If the warp wire had a smaller diameter, the opening would close more. And if the diameter was bigger, the openings would be even larger. Actually, I don't think that's possible, but you get the picture. So, in conclusion, these variating multi-diameter weaves actually dictate how large the openings are going to be in filter cloth. Pretty cool if you ask me. So if you want to figure out precisely what the wire diameter is for your mesh, this is what you do. For the larger wires, you can use standard calipers. Just firmly close the jaws onto the wire to get a standard reading. This wire in particular is 0.206 inches in diameter, and if you push this button, it's 5.23 millimeters in diameter. But if you want to measure very fine mesh that gets under 0.001 inches or about 25 micron, then we're kind of getting past the territory that general calipers are certified for. So for that, we'll want to use micrometers. And they work the same way as calipers do. But you'll want to be very, very gentle. When clamping the jaws on a wire this size, you could potentially crush it. As you can see, I've just pulled one of the wires out of the weave so we can get a clean measurement. But once you feel you've gotten an even grip on the wire, you'll see that this wire's diameter is 0.00115 inches or 0.028 millimeters, or about 28 micron. And that is wire diameter. It's one piece to a greater whole, but equally as important as any other part of woven wire mesh. But we've only covered half the base of woven wire mesh. In the next episode, we're gonna go over the other half that makes woven wire mesh, and that's aperture size. You're not gonna wanna miss this one. So glad you stopped by, and I'll see you around in the next episode. Bye for now.